Good evening, students. Today we are going to start the chapter probability. This chapter is very easy. So whatever the concepts we have learned in class 9th, in addition to that, we have to learn few more concepts. So we'll start with what is this probability, how it is related to a random experiment or any activity, then how to write the number of elements in this random experiment called as sample space, then how to write the element of event, then the ratio of number of elements in event to number of elements in sample space is called the probability of that particular event. There is another kind of probability defined for any event called probability of not occurrence, that is obtained by subtracting the probability of occurrence from 1. So these things we will learn. In addition to that, we have to learn one more new concept of the game of cards. In this game of card, there are total 52 leaves or 52 cards. They are in 4 sets, and these 4 sets are in 2 colors. One is red, another one is black. So red is again divided into 2 groups. One is called the diamond, another heart. Even each of these diamond and heart is having 13 cards. And same for the club and a spade, means the 13 card which is black in color. So what is 13 card? What is the probability of getting that? This 13 card, the very first one is ace, then king, then queen, then jack, then start from 10 to 2 or 1. 1 itself is called as the ace. So all these things we will see. So a student, what is this probability? The English meaning of probability is simply the chance of occurrence. What is the chance of occurrence of any particular activity or particular event? Now, this chance of occurrence can be quantified in mathematics with the help of ratio. So this ratio is the number of occurrence by total possible occurrence. It is that way. This can also be expressed in the term of percentage also. Percentage means the ratio have to be multiplied by 100. It is this one. Now, for understanding this probability, we need to first understand what is an activity that we are performing whose outcome cannot be predicted. Means only the chance can be told. So such any activity whose chance can be told, not the exact outcome can be told, they are called as random. Random simply means the occurrence is not very sure. There could be more than one possibility. So this probability is dealing with that kind of event. Example, in a box, say 4 colored balls, one is black, red, green and white, are placed. And you are asked to draw a ball from that box without looking it. Then can you get the white ball? Or surely can you get the white ball in the very first draw? Or is there any chance that the white ball will not come or some other ball will come? Yes. So while you are going to draw one of the ball without looking the color, there is a chance that out of this 4 ball, any one ball may come. That may not be your white. or it may be white, even in first draw. So what is the chance that particular ball will come? That is expressed in the term of probability. So that's why this probability is always dealing with the event or activity. That activity is called as random experiment. So random experiment or activity. The term random tells that the outcome cannot be predicted. The outcome is not sure. So whose outcome is not sure. That is not only one, that is it can be more than one. In that, few will be desirable for us and few may not be desirable. So few or some is desirable or required. So this required outcome is called as favorable event. Okay, and few of them are desirable and other are not desirable, or even not required. So such any experiment or event or activity which can give the set of outcome, if we are collecting all the outcome or all the possibility, then that set is called as sample space. Means what? The things are very simple for this random experiment activity. So any activity which gives a set of or a collection of, this collection word is sometimes used as the set of outcome or possibilities. Set of possibilities. These possibilities are basically the outcome, and only some of the outcome are desirable. Say I want to draw a ball from the set of 4 different colored balls. That I may get the other color. So wherever outcome means in addition to our desirable, some other outcome or other possibilities are there, then such experiment or such activity is called as random experiment or random activity. Get it? So activity which gives a collection or set of possibilities in which some are required, in which some are desirable or required, and other are not required. Get it? So the two things is there. Some maybe only one or maybe required, that I need out of 4 color, I need the 2 color and 2 ball are drawing at a time. So maybe more than one also. So we have written this some are required. So wherever we are concentrating or considering the required outcome, if we are just enumerating or writing that set is called as event. But writing the all possible set means the required as well as though not required, but surely that will occur, or there is a chance of occurring that set or that collection is called sample space. So in this definition, everything is there. So you have to just understand. This definition is mathematical and very, helpful. Just you are understanding what is this random experiment, what is sample space, everything you can just understand by this single line. So any activity that we are performing whose outcome is not fixed, that may give some desirable outcome and some undesirable outcome. If we are collecting all this desirable and undesirable outcome, that set, the collection of all outcomes is called what? This is called sample space, student. Okay, sample space, and the sample space is denoted by S. Okay, and if we are interested in collecting that part of outcome in a separate set which is desirable for us, then that set means collection of required outcome is called event. So event is nothing, but here we are able to observe event is the part of this sample space. It's so simple kind of thing. From this you can conclude that if the event is part of the sample space, therefore for defining the probability, part of anything is always lesser than 1, or maximum it can be 1. Therefore probability is always lesser equal 1. Are you getting? So this is very important. So here we have learned two things. Any activity that we are performing is called as the random experiment. The desirable outcome, if I am collecting it and writing in one part, that will be called as the event and denoted by E. These outcomes, their number can be counted. Then that is denoted by NE, number of element in the event E. The set or the sample space is also a set. In that, or a group, how many members are there? That is denoted by NS, number of members or element in the sample space. So a student, understand this. Random experiment simply means all possible outcome where the outcome is cannot be predicted. It gives the required and not required. The collection of these two gives the sample space denoted by S, and their total number can be counted. And wherever we are concentrating over the required one, then it will give us the event. Get it? It is this. I'm going to take an example. I will write there sample space, event, everything in this single. It is not class 9th where I shall define random experiment separately, write that one, then event that one. That we have discussed in class 9. So collectively we will revise all this topic or this thing. The students, example, I am considering just a die is thrown. Die is thrown. Then you are knowing that this die have 6 surfaces, means it is cubical in shape, and on each surfaces one number is written, and that number varies from 1 to 6. Okay, 1 on each surface. While this is thrown without looking, then it may be possible that at the top it could be 1, or it could be 2, or it could be 3, or it could be 4, or it could be 5, or it could be 6. So these are the 6 possibilities. So these are the possibilities. Okay, it is this one. So this is all possibilities basically for one die I am throwing. But if someone is specified that in the game of Ludo, that you are able to move forward, or your count or your chance starts only if you are getting the 6. So 6 is what a condition which is desirable for you. So collecting this 6 only in other set so that you can move further, collection of only this particular element is the event so that you can move ahead. But all possible outcome, if you are writing this in one set as 1, 2, 3, 4, 5, 6 in collection form, denote it within the symbol of set or a curly bracket. So it is forming a group or set. So this set is called as your sample space. Sample space. But you can move only if the 6 you are getting. So 6 is an event. There may be any number of events for particular sample space that we will also understand. So sample space is this one, means 1 to 6. How many elements or member are there? What are the member? The member could be 1 or 2. Member means the outcome or the track. Or it could be 3, means one particular outcome or track. Collection of which gives the total possible outcome. So it could be 1 or 2 or 3 or 4 or 5 or 6. So total 6 means the number. So that number of outcomes in the sample space is denoted by NS, and it is this 6. Okay, do not confuse that this 6 is same as this 6. Since the number is here starting from 1 and going to 6, therefore it is matching, but need not be always like that. If the die is numbered from say 8 to 14, still the number of outcome can be 6 only, though you may get 8 or 9 or 10 or 11 or 12 or 13 or 14. Okay, it is this. So student, the thing is that here the event is what? It was the condition. So condition given from this sample space, it is total outcome, means without condition. Say just a die is thrown, what are the total outcome? Total outcome that gives the sample space. So total outcome we have enumerated within a set. This we have written like this. Within a set we have written it. Then it is the sample space without any condition, without stating any condition. Now condition was imposed over you that you can move ahead only if you are getting the 6. So your desirable thing is only 6. So 6 will be one of the event. Here this I have taken. One may told you that you can move only if you are getting the even number rather than 6. Okay, the condition may be changed. So second condition I am taking, say getting even number. The getting means the number on the top. Okay, so getting even number means out of these outcomes. What are the outcomes, student? Come here. The outcomes are this one. Out of this, what is the condition? The condition is even number. Even number have to be searched from the sample space only. Do not think for the even number of any kind, starting from 0 to 4, 6, 8, 10, like that. No, this even number, these have to be from sample space only. That condition have to be observed from the sample space. Now collect the even number from the sample space. What they are, you can mark it. 2 is the even number, another 4 is the even number, another 6 is the even number from the sample space. So writing that separately in another group or in another set as 2, 4 and 6, this is denoted by another set as E, called event. It is the event. To differentiate means this way we can write n number of events depending on the condition we are imposing. Okay, so considering the condition, different events are considered. A student, here we are observing that event can be any number, means event can be of any type depending on the condition, even for the same sample space. So to differentiate this event first from the event 2, sometimes we are putting the E1, means substitute or put a suffix 1 in first case and put a suffix 2 in second case. Okay, so this way the suffix are used to differentiate different event for the same sample space. Is it okay? So like the number of members or element in the sample space, the number of members in event can also be calculated. Like here, for this first one, number of elements in the first event, the event was getting 6. What was the condition? Here it was getting 6, only a fixed number. So number of element in this first case of getting 6 was 1 only. Is it okay? But in the second event where we have considered the outcome can be any even number, in this how many elements are there? 1, 2 and 3. So number of element in this event 2 is our 3. Ready? So just counting the number we are able to get this. Then for a particular event, we are defining the probability. Probability tells the chance or percentage occurrence of that particular event in given sample space. Okay, student? So, right, how the probability is defined here? So, probability probability of an event is chance of occurrence and expressed as, so how to express any kind of chance? Means the fraction of sample space and expressed as fraction. Fraction is same as the part, you can understand, or dividing the part or fraction, decimal it can be. Even multiplying it by 100, we can write in the term of percentage. Out of the total possible outcome, what is that? Sample space. Out of the total possible outcome. It's so simple kind of thing. These concepts are very helpful rather than just mugging up the formula. If you are understanding this thing, you can express it easily. Not only express, you can anticipate what is basically asked in question. So therefore, in symbol form, probability is always associated with particular event, and it is denoted by probability is associated with any event, and it is occurrence of which one, which is desirable for us. So it is the required outcome, sometimes also called as favorable outcome divided by, for the same experiment what we are doing, or random experiment, the total possible outcome. So the definition is like this. In symbol form, for particular event E, if we are writing, it is written as number of element, because event is the collection of desirable only. Therefore, number of element in event divided by total possible collection is this set of sample space by ns. Is it okay? It's so simple. Since we are knowing that, or we have observed that any event is always the part of sample space, so maximum possibility is what? Up to the event. So since number of element in event E is always less equal than number of element in sample space. Why? Since event is a part, or maximum could be equal, or maximum could be equal to sample space. Therefore, taking their number wise, that will also follow the same relation. N is less equal ns. Additionally, it is possible that there could be an event in which there is no element, like a die is thrown and chance of getting 0, or event of getting 10. What is that? So in this 2, let me write one more event for this. Come back. So for the simple experiment of a die is thrown, the event of even number we have written 3, event of getting 6 we have written. Third, if I am writing event of getting 8 in a throw of die, a die means the single die is thrown, we want to get the number 8. Is it possible? Event E do not have any element to write inside this. We have to write E as this one. This is sometimes also denoted as, right, and cross it as 5. What is the number of element in this? It is 0. So it is possible that the event may not have any member. So it is possible. So therefore, it is possible that, come back to this one, since NE is less equal NS, and here we have also understood that NE can be greater or equal 0. Is it okay? It's all. Now divide this inequality by NS. So sorry student, it was on network issues. So we were discussing about the probability while we are throwing a die. Here we have understood that while throwing a die, the event depends on the condition we are imposing. Like if we are imposing the condition of getting even number, we are getting the event in which the number of element is 3. If we are just giving the condition of getting 6 only, then number of element in this event is only 1 and it is 6. If we want to get 8 in the throw of a die, then there will not be any element belonging to this set. Means the number of element in this event is how much? It is 0. So the number of element in any event can vary from 0 to maximum number of element in its sample space. Therefore, we can write like this. This 0 greater equal any, less equal ns. Go on dividing it by ns for this inequality. The first one becomes 0. The second one, any by ns, become PE, probability of event E, and ns by ns getting cancelled, it becomes 1. So what we are observing, the probability can vary from 0 to 1. Point number 1 that we have to keep in. So therefore, the probability will always be in some fraction or in decimal. It can be 1 under certain condition or only under few occasions. There is other way of expressing this decimal or fraction, that is called as the percentage. How to get that percentage? Means the percentage probability can also be expressed. So percentage is obtained by multiplying the given fraction by 100. It's so simple. Therefore, for expressing the probability in the term of percentage, I have to multiply this ratio by 100, and surely we have to put this percentage sign together. Example, say probability of event E is, say, 30%. What does it mean? So it is same as 0.3, or it is same as 3 by 10. So all are 3, means all are the same. So writing 30, you cannot simply write as 30. Means probability of event, can it be 30 only? No. If you are writing only 30, then it becomes wrong. Why? It will violate this inequality, that probability cannot exceed than what. But percentage term indicate it is divided by 100. Okay, student? So that's why, means any kind of percentage always indicate whatever the term x is there, that is divided by 100. Therefore, 30% means 30 divided by 100. So 0, 0 are getting cancelled. It is 3 by 10. Or in decimal, it is 0.3. Okay. So this way, the probability can be in the term of percentage, or in the fractional form, or in decimal form. These are the ways of expression. Now, few more things that we have to keep in mind. Here, the probability of an event could be 0. And such event whose probability is 0 is called null event. Okay? Or phi, or empty event. Empty event. Like probability of getting 8 during throw of a die. What is that? That is a null event. Getting? Probability of raising sun in west. Is it possible at any cost? No. That is a null event. So null event means those events whose probability is 0 is called as null event. It is possible that this probability can be 1 also. If that is the condition, then such event is called as sure event or universal event. Example, the probability of rising sun in east. surely it will rise in east. It is universal truth. So expressing the probability means it is 100% true. So probability is 100% or probability is 1. So such an event is called as universal event. So these are the two terms that we need to keep in mind. Universal event means those event or those experiment or those activity in which the occurrence is always 100%, means the simple space is matching with that event. Okay? It is that. So these are the two terms that we have to keep in mind. How to express probability, that I have also explained. Now there is another way of expressing this probability. So how much probability is occurring? So expressing this way, it is called as the probability of occurrence. Probability of occurrence of event E. The E need to occur, or simply the probability of event E. Event means it shall happen. There is another way of expressing the same probability from the universal set, that is called as not occurring that event, or the complementary event or complementary probability. So right, complementary event, and if we are calculating the probability for this complementary event, it is called as complementary probability. So complementary probability. This complementary is always with reference to some event. The complementary term means the remaining of particular event. So it is always with reference to some event. Some event. So event is required to be happened, but this complementary tells not happening or not occurring happening of E. Get it? The probability for happening an event was denoted by PE. So not happening is denoted by putting a bar over it. So not happening an event is denoted by the set E with bar over it. Example. Let me write the example that I had taken. We are throwing a die. In throw of a die, the probability of not getting even number, the event and probability for not getting even number. This is the condition. Means what is here? Not getting even number. It is what? So not getting even number is what? It is opposite to, or this is complementary of getting even number. Means if I am writing for getting even number, what was our set? Our set was 2, 4 and 6. Then not getting even number, how I can get? For a moment, I'm not counting directly. I want to count it indirectly. What was our simplest space? Simplest space was 1, 2, 3, 4, 5, and 6. These were the simplest space. Now, complementary to this E means you have to remove all the element of E from this S. Means complementary is equivalent to, you can understand, simple space minus event. It's simply meant. So here, if I want to get the complementary of this event E, it will be denoted by E bar. And how I shall get? I shall get by removing the element of E from the S. Means E minus S. Here minus, not the number minus, removing the element which from the S which is falling in E. So 2, yes, 2 is here, and the 2 from the sample space need to be deleted. So delete it. The 4 from the event, this 4 need to be deleted from the sample space. So 4 is deleted. Coming for the third element, what is our 6? The third one is our the 6th one. So delete this third from the sample space also. Now what are left in the sample space, student? The left element are, or remaining element are, not 2 we have already deleted, so 2 should not be written. What we shall write next? 3, 4 shall not be written. 5, 6 should not be written. So whatever this event or this new set that you are getting, it is just complementary to this occurrence. So not getting even number is what? Can be even written directly by removing the element, or just checking the number is not even, then we can write. So this even we have to write, check from 1 to 6. 1 is not even, we shall write. 2 even, not right. 3 not even, we shall write. 4 even, so we shall not write. 5 not even, so we shall write. 6 is again even. It's okay. Up to sample space we shall go. So this we are writing this way. Ready? So not getting event can be calculated directly by observing the sample space, or may be obtained by subtracting the event of occurring, means event of happening, from the sample space. Therefore, the convenient way is denoting this with the help of E bar. So what we are observing? If we count the number of element, so in this case the NS is our 6. For the event E, NE is our 3. And for the E bar, NE bar is also our 3. What we are observing? If we are adding this NE and NE bar, what we are going to get? We are going to get NS. So complementary event is always for a specific event, getting, which is obtained by subtracting that event from the sample space. It's so simple kind of thing. Therefore, the sum of element in event and sum of element in its complementary event is always equals to the sum is equals to the number of element in its sample space. It's so simple. Get it? Now applying the condition, what is that? Dividing each and every term by NS means NE plus NE bar by NS is equals to NS by NS. It simply means on left hand side, numerator is the 2, so divide the denominator for each of the numerator, NE by NS plus NE bar by NS is equals to right hand side, these two are getting cancelled, so what is left is 1. NE by NS is what? It is our probability of happening that event denoted by PE. NE bar. What is this representing? Complementary part of that. Therefore, it is also denoted as, in the same fashion, PE bar is equals to 1. Therefore, probability of not happening at event can be calculated from 1 minus probability of happening. So no need to separately calculate the complementary set than finding the probability. This formula tells that the probability of any complementary set can be obtained by subtracting the probability of that particular event from 1. This is the other formula that we need to keep in mind. Many times this is very helpful, exclusively when the event is having very large number of elements. Then sometimes we are calculating their complementary event, then even we are calculating their probability. Or reverse way we can also write, or rearranging, PE also becomes equals to 1 minus PE bar, because P plus PE bar is 1. So one side you have to keep the bar, other side without the bar, and 1 minus that PE or PE bar you need to keep in mind. A student, like it may be asked, how many non-prime number are between 1 to 100? How to count? Will you start counting the non-prime number like 4, 6, then 8, then 9, then 10? Will you count that one? Or will you want to count the prime and you are knowing total there are the 101, is including 1 and 100? Then just counting the prime, subtracting it from the 100, you can get it. So this complementary event is even useful for calculating the required event also. Wherever the counting of this not happening is easier, we are using this. Say, in your class, it may be possible that there are total 50 students and a person is asked to count how many boys and how many girls. It appears that the number of girls are lesser in number than whether the intelligent person will try to count the number of boys or number of girls. He will try to first quickly count the number of girls, then subtract that number of girls from the 50, get the number of boys. So this concept of complementary is helpful in case of or under the condition where one of the event can be counted easily, the other can be obtained, or the bigger one can be obtained by subtracting it from the total. Okay, this is the concept. So this we have to keep in mind. So these are the things that we need to keep in mind. Now let us come for the another a small thing called the card or game. A student, that is the final concept. After that we will go for solving the question. How to apply this concept, that we will see. So game of cards. In this game of cards, there are total 52 cards in 2 colors. So it is in 2 colors. So color wise, if we divide it, one is red color card and another one is black color card. Okay, it is found that total 26, means half of this 56 is red color card and the other 26 is black color card. Okay, just keep this much in mind. Again, out of this red color card, half of this is grouped into one group called as heart, and the other group is called as diamond. Means the 26 is now divided into two. Means 13 red color card is of the heart. 13 red color card will belong to diamond. Then to identify these sets, there must be the symbol of this heart. So this symbol of this heart, how is this heart? This one. This is the heart. Are you getting? Or symbol for means on each of these card, this symbol will be present. Getting? You are knowing that card is this way rectangular, and their symbols are given on these corners. Okay, these opposite corner. These are the symbols, or basically the group symbol. This is their group symbol. So there are total 4 group. Means here we have observed these 52 cards get divided into 4 groups, 13 each. 4 groups, 13 in each group. Their group symbol are marked at their corner. Here I have drawn for the heart, the group symbol. Similarly for the diamond, it is the rhombus. It's the simplest one. The black color is again into the 2 group. One group is called as club or clubs, and another group is called SPAT. The club have the symbol of 3 leaves with this is the symbol for club, and for the SPAT, inverted heart with handle. Draw this. Are you getting? It is like this. So this heart is of the red color. Let me fill it. These 2 are of red color, and other 2 are of black color. Okay, student. So one is, or the question may arise with, find the red color. So irrespective of whether it is heart or diamond, you need to count both. It may be asked to count the club, then in that condition you need to go for the black card, but not all the black, you have to leave the SPAT. So you should be careful while you are asked for these terms. So these terms are very important. Their color is one thing, then their group name is the other thing. Now in this 13 card, what are their members? What these 13 card are and what are their significance? Let us understand that one also. So students, you have to keep in mind their color. So these are the 4 colors or color card. It is basically the 4 group of card in 2 colors. If it is asked for black spade, then surely you shall count for the spade one, or only a spade, then surely it will be the black. So depending on the condition. Now these 13 card, the highest or the most powerful or the maximum worth card is called as S. So this S is always numbered as 1. It is commonly written as A also. So for each group there will be S. S of diamond, S of heart, S of club, S of spade. Right here it has maximum worth. Maximum worth. Okay, it is that one. Then the next to the S, it is the king. The second card is, or second most powerful card for each group is king. Must be written K. Okay, so the K for diamond also, K for club also, K for spade also. So student, how it will be written? So the symbol will be come to this figure regarding this card. So drawing this card. After drawing this card, there is some position for their symbol. This is the card that I have taken. Consider this is the card. Symbol area is their corner on the opposite. One thing. So say king is to be written king of heart or king of diamond. So K will be written in the center and the diamond will be drawn here. It will be something like this. Or in many of the card, even the K is written at this corner also. So it depends on the card design. Nowadays, various kind of cards are there. Means the information will be there whether king is of the heart or king is of the club or king is of the diamond. So 2 things are drawn on the card with various other smaller design to look it attractive. The next is queen. Q. 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 The next jack is in the lower hierarchy. J. 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 The next below this they are numbered. So numbered card. Numbered. What they could be? They could be 10. Here also 10, 10, 10. It could be 9, 8, 7, 6, 5, 4, 3, 2, and 1. Student, the same thing. 9, 8, 7, 6, 5, 4, 3, 2, and 1. Means these 2 are for the red card. One is belonging to heart group, another is diamond group. Coming to the club group or the black card, up to 10 we had written. Next will be 9, 8, 7, 6, 5, 4, 3, 2, and 1. The same is also for the other group, which is the SPAT. Right, for the SPAT up to 10 we had written 9, 8, 7, 6, 5, 4, 3, 2, and 1. A student, keep in mind 1 need not be repeated, because what is this 1? This is identical to your S. Okay, so 1 is not used, rather it is called as ICA or S. Okay, student, already S have the highest priority that we have written. If you count it, 1 is S, then 9, 1 is this much, the numbered card, and these 3. Total 10 and 3, 30. Here we have to keep something in mind. What something? A student, sometimes the term like face card is used. So write that term. Face card. Which of this card have the picture of face? Face could be for the king, or maybe for the queen, or maybe for the jack. So these 3, this group of each kind means each of these set have, these are the face card. These are face card. Okay, so keep in mind the face card is asked. Then how many face card are there total? Total 3, 4 are 12. Total 12 face card. Okay, so right, 3 face card for, so this 1 is not required. The student, keep in mind ICA need not draw again. So right, 3 face card in each group. What they are? They are king, queen, and jack of each. If it is asked face card of red color, example, if it is asked, the event is for getting the face card of red color. How many face card of red color will be there? No one is knowing? A student, this heart and diamond are of the red card. Heart also have the 3 face card. Diamond also have the 3 face cards. So total 6. Getting? Then if it is asked total queen, so total queen in this set is how much? 4. So depending on the condition, we have to search the numbers and the card from this. So keep in mind, so total 12 face card. Out of this, 3 face card for a SPAT, 3 diamond, 3 club. That way we have to understand. In terms of if the color is asked, so this 6 red face card and 6 black face card. So only this much thing is enough for you people to anticipate any kind of game based question. It is one thing. Okay, student. So this was all about the concept in addition to our class 9th, whatever we had learned in our class 9th. Student, the same thing is also written in your textbook, but in a very concise manner that I had explained it. It was this one. See? So 52 card, which is divided into the 4 group or 4 suits of 13 card each: SPAD, heart, diamond, and club. Club and SPAD are black color, while heart and diamond are red color. The card in each are as king, queen, jack, 10, 9, 8, 7, 6, 5, 4, 3, and 2. One is equivalent to S. Okay. King, queen, and jack are called as the face card. It is the summary of the explanation I have given. A student, many a time our students are facing difficulty in writing the sample space and event. So I'm going to write few sample space. So few events and sample space. Few sample space and events. Let me write before going to the question. Okay, student. So the concept of sample space is very simple. Total possible outcome you have to search. In this case, total possible outcome you have to search irrespective of the condition what is asked in the question. Say the question is throwing 2 die simultaneously or throw of 2 dice. You just blindly, irrespective of the condition required in the question, first you make the sample space. What could be the pair? Then event, the condition, apply the condition and search it from the same sample space. So with condition from sample space or outcome of the sample space, that you have to write separately. Okay, let me take few example. The first, you are already knowing, throwing of coins. So let me start with the throwing of 2 die. Throwing of 2 die rather than 1 die. If it is said that 2 dice are thrown together, then what could be the sample space? How we shall take? A student, each possible outcome you shall consider. See, the die 1 and this is the die 2. It is possible that I am throwing these 2 die together and observing the number on 1 die and another die. Or let me draw 1 die at a time, then once the second die. Observe the number on first and second. So one pair will be formed, that is okay. Okay, students, I was considering the event of throwing 2 die. It is possible to draw the 2 die together or draw these 2 dice in succession and observe the number. Let me draw the first, or let me throw the first die. I observe the outcome is 1. After this 1, I am observing on the second die. It may be possible that after getting this 1 on the first die, the second die may give the 1, or even keeping 1 on the first die, I may give the, or I may get the 2 on the second die. This is the other possibility. Or even keeping this 1, I may get the 3 on the second die. Keeping this 1, I may get the 4 on the second die, or I may get 5 on the second die, or I may get the 6 on the second die. What we are observing, may keeping 1 on the first die, I may have the 1. Keeping 1 on the first die, I may have the 2. Keeping 1 on the first die, I may have the 3. Or keeping 1 on the first die, I may have the 4. 1 on the first die, I may have the 5. Keeping 1 on the first die, I may have the 6. So these are the 6 possibilities. Even on first die, there is 1. But there is fair chance that on first die, there is number 2. So even same thing can happen for the getting 2 on the first die. For 2 on the first die, the second die may have 1. may have 2, may have 3, may have 4, may have 5, may have 6. Likewise, means 2 on the first die, the second die have 1. So this pair indicate the outcome on first die and this on the second die, means the D2. This way. So you can write it 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. So, okay, student, these are the things. So, how to write this? To write this in compact fashion, the method adopted is writing in the matrix form. So, taking this one on this side, means on this vertically downward, I am putting the outcome of die 1. What could be its outcome? Its outcome could be 1 or 2 or 3 or 4 or 5. It could be this. On the second side, means the horizontal side, I am putting the die to their outcome, means individual outcome. I may get 1 or 2 or 3, that way. So let us write 2 or 3 or 4 or 5 or 6. Then this pair can be allocated easily, means on the first die, keeping 1 on the first die, I may get 1 here, means 1, 1. This is one pair. Keeping 1 on this first die, I may get 1, 2. Keeping 1 on the first die, I may get 1, 3. Keeping first on the first die, I may get 4. Keeping 1 on the first die, I may get 5. Keeping 1 on the first die, I may get 6. These are the possibilities for 1 on the first die. The same thing can happen for getting 2 on the first die. So we have to write for that one also. The same for the 3 on the first die. That way we have to write. Means all the pairs we need to write. Means 2 on the first die, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. Then 1 on the first, 3 on the first die, 3, 1, 3, 2, 3, 3, then 3, 4, 3, 5, 3, 6. These are the possibility for 3. Then for 4, 1, 4, 2, 4, 3, 4, 5, 4, 6. Sorry, correct it. 1, 2, 3, 4, 5. It is 4, 4, 4, 5, 4, 6. Be careful while writing. Do not miss. Similarly, we have to write for the first outcome as 5, then for the 6. Let us write for the 5. On the first die, 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6. On the taking 6 on the first die, 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. Are you getting? These are the outcomes. So outcomes should include the information of both first and second. Now for these outcomes, various conditions are imposed. Say getting the paired number. Okay, say paired or pair of equal number. of equal number. This pair of equal number is also called as doublet. Okay, means two the same number. What they are? If the condition or in the question, if it is asked for the pair of equal number, then you shall search. So on the first it is 1, the second also it must be 1. On first, keeping 1 and any change in any number, that will not be the same, means in this remaining it cannot be anyone. Coming for the first die outcome as the 2, then second also shall have the 2. So it will be only this number 2 2, remaining need not be counted. So it can be 2 2, 2 is over, so 3 3, 4 4, 5 5, and 6 and 6. So these are the 6 doublets we can get. It may be given that outcome on second is double of the first, or outcome on second is half of the first. So second outcome half of first. If it is like that one, then how the half of first? So on first, if you are writing as 1, then the next it should be 1 by 2. Is it possible? 1 by 2 it can never exist on this second. So this is not there. So what we shall take? We shall take it 2, then it is 1. So this you can allocate even from this one also. So 1 can never get 2 and 1. It is this one. Another 3, 3 by 2 not possible. 4, then 2. It could be this one. The next one 6 and 3. It could be this one. So it could be 4 and 2, then 6 and 3. Are you getting? So this way, whatever the conditions are there that you need to write. So these are the events that I'm writing. Okay. So let me write this as event 1, this as event 2. Any kind of event we can write. And whatever this table we have written, before that you just write S. That's all. You draw this, write S equals to this. Count how many pair are there in this sample space. Count 6 rows, 6 column. So total 6 into 6, it becomes 36. So NS 6 into 6, it is 36. It is the number. Similarly, if it is asked for number of element in first event, how much is there? 1, 2, 3, 4, 5, 6. So it is 6. Number of event 2. It is 1, 2, 3. It is 3, 1. It may be asked for calculating or some other condition. Let me take one more condition. The third one is sum of numbers or sum of the outcome should be 9. Let me take the 8. Means if you are taking the first number on first die as X, second die as Y, then the sum should be 8. Okay, or number 1 plus number 2. But this X can vary from 1 to 6, that we are knowing. We have to choose suitably. Y can also vary from 1 and maximum to 6. But we have to choose the number suitably from this 1 to 6. So what could be the pair? So that way the pair XY we need to search. So if I am choosing 1 on the first die, then second die must have 7 to get 1 plus 7 as 8. Means we have to choose XY such that X plus Y is 8. Choose 1 on the first, others shall have 7, but 7 is not there. It means this choice is Wrong. We shall not choose this. What we shall go? We shall go for increasing this outcome. On first die, I am choosing 2, second die 6. Yes, possible. On first die 3, second die 5. On first die 4, second die 4. On first die 5, second die 3. First die 6, second die 2. It's okay. Keep in mind, student, these are ordered pair. Means in this pair, 2, 6 and 2. These two are different. Getting no? Because first one is from the first and second one is from the second. So these are the ordered pair. So ordered pair. So do not think 2 and 6 is same as 6 and 2. No, these two are different. We have to count it as 2. So in this case, this is the event E3. Put it into a bracket. What is the number of elements in this event? As counted 1, 2, 3, 4, 5. It is above 5. So this is the way of considering the event after writing the sample. So drawing two die was important. Even 3 coins are tossed together. 3 coins tossed together. We have to stop the class also. 3 coins means you may consider this coin as coin 1, coin 2, coin 3. That way you have to just write. It is possible that on this first coin, this as the second coin, this as the third coin. It is possible that on first coin you are getting the head. Okay. For this first head, you may get the head on the second coin, and on third coin you may get the head. Or it is possible that in first coin you are getting the head, second coin head, but on third coin you are going to get the tail. Okay. So therefore, always write by changing the only one element at a time. Means on the first is head, second is head, third is tail one. So how to write for this? It is just HHH is written. This is HHT is written. First head. After keeping the second head, the third could be head or tail. That is already counted. So surely we have to change for the second coin as tail. Then on the third it could be head, or on third it could be tail. So it should be written as HTH or HTT. Means the H and T are maintained. It is like this. So even for the, so first we have started with the end. Here we have changed. Okay, we have got the 2. Changing at this position means head to tail. We are getting total this much. Now it is possible to change at this position. Okay, so these changes are important. So observing. So even on the first one die we have the tail. Then on the second, for changing this, remaining all these 4 possibility are true for this tail also. So we have to write all these 4 once again. Student, just write it. It could be head and tail. So it could be tail. Sorry, it could be head. Let us take the order wise. Head. So tail, head. Then tail. This with this one we have written. By changing this, so tail with this head and tail. So tail, head, tail. The next one, for this one we can write the tail, head. This one tail, head. So T, T, H. And what is for this final one? Sorry, the fourth one is our this one. Here we can change this one. My page is full, so I am writing here. So it can be tell, tell, tell. Therefore, the total outcome just that we can write here the sample space. This is the total outcome while 3 dice are thrown. The question may be for selecting the 2 tails together in throw of 3 die. So those outcomes which have the 2 tails should be counted. It's so simple kind of thing. So write down, this is the sample space, total outcome that we have written is HHH, HHT, HTH, or HTT, or THH, or THT, or TTH, and TTT. It was all. Okay. Now, depending on the condition, you can write the event. So these are quite common. Okay, student. So it is the second thing that we need to keep in mind. Now let us go for the another simple kind of thing called sample space counting when certain numbers are given. Okay. So sample space from numbers. Sample space from numbers. So in this case, you need not write the sample space one by one in the set form. Rather, you just calculate the number of element in sample space, number of element in the event. Like a bag contain 5 red, 10 blue, 12 green, and let me take one more color, and say 12, 17, 3 only. 3 white ball. White ball. It is this one. So in this case, no need to draw the 10 red ball or 10 blue ball, 5 red or 12 green ball. It is just the direct information is given to us. Means it is like this one. So a big ball is, so a big bag is there. You may draw like this. The bag as a circle I have drawn. This is the bag. In this bag, there is 5 red, one information, 10 blue, and 12 green, and 3 white. That's all. Here it is already in number. So this box is acting as our sample space. So NS is simply obtained by adding this. 5 plus 10 plus 12 plus 3. Add it. So 5, 3, 8 to 10, 20, 30. So 30 balls. So this way the sample space, rather than writing the or putting 30 dots, we have just obtained the sample. Number of element in sample space. Now getting red and blue ball. Say the event is like this. Or let me take the event of getting red or blue ball. We are interested in drawing 2 balls together. Means red or blue, both are acceptable to us. means this red or blue, these numbers are in our favor or required. So what was in our sample space? The 5 red, I am just rewriting it, 10 blue, 12 green, this was our sample space, 3 white. So from this I need this red, so red and the blue, only these two should be taken in our event. So if I am drawing this event, means I shall consider only the part. Which part? This much part only. This need not be in the same order, maybe placed separately, and you are just blindly drawing it. So the event contains 5 red and 10 blue only. So what is the number of element that the event can have? It is 5 plus 10 is equals to 15. So this way the event need to be counted. Let me take the one more event. Let me take the event B. Ball should not be green or ball should not be blue. Event that the ball drawn should not blue. A student, here we are given with ball should not be blue, means blue should be excluded, remaining all are acceptable, means ball can be what? Exclude the blue. So blue is this much part. So these 10 have to be excluded. It can be red or it can be green or it can be white. Red is here 5 in number, green is 12 in number, and white is 3 in number. If this is the condition, the number of element in this event E2 I am denoting, just add it, 5 plus 12 plus 3. How much is this? So 820. Okay, so this is the event, but there is other way of doing this. Not blue, this is the method 1 where we can count directly. The method 2 in which not blue can be counted by total minus blue also, because this counting is easier. So number of not blue, so blue that not is required is the total. Total is how much here? So total as our NS, we can write in this symbol form as NS minus event for blue. See whether this is giving the same result or not. NS is our, we have written here, it is our 30. So it is 30 minus, and blue is given here 10. Okay, minus 10. What we are getting? Same as 20. It was same as direct counting. Okay, student. So these two are there. So these are the things that we need to keep in mind. With all this, I had explained all the concept, even revised the class 9th concept. Now let us go for some of the questions which are very easy. So let me, the other question you will try as homework. They are very easy questions. Let me give the hint. Other we will try, and next day we will do the more questions. Let us do the question number 8. First, you shall observe carefully for sample space, then event, then apply the formula. Do not blindly just write the ratio. That always gives the wrong result. But if you get the skill of writing everything correctly, you will always get the correct result. So a bag contains how much? 3 red balls. So for that, you may write this: 3 R, 3 red, 5 black, 5 B ball. So you may put it like this. It is forming a set. After drawing this, you can write NS. Only these two information are there. Is equals to 5 is equals to 8. The ball, a ball, see, single ball is drawn at random from the bag. What is the probability that ball drawn is red? So write the first part. What is event? So you have to write this as E1. Event of getting which one? Red. So we are interested with the red part only. In our event, the red one is only 3. So this implies N of E1. What is your E1 denoting? What is your E2 denoting? That you have to write. Okay? Is our, just write the number. Therefore, probability of E1 is N E1 by NS. After this, you have to substitute the value. It is our 3 by 8. Here you can leave, or even you can divide it, or even you can multiply it by 100. So this way, or go for dividing. So 3, not divisible, no, point. Then how much? You have to just divide it. 0.375. This way, it may be in the decimal, or many a time it is expressed as the percentage also into 100. While writing like this, you have to put the percentage sign, because percentage indicate divided by 100. So 100 are getting cancelled. So percentage is always greater than 1. So go for doing this. You will get this as, multiply it 300, or you will get this as 37.5%. All the 3 are possible ways of writing your answer, and in your textbook or in answer, maybe in any of these. Even in the MCQs, the option it may be in either of these forms. So do not always think for the fraction. So questions are so simple, student. Let me do the second part of also. Not red. A student, probability of not red. So it was red. It is just E1 bar. It is this one. This will give not red. Not red. 1 minus P E1. If we have already calculated, so 1 minus 3 by 8, you will get as 5 by 8. This is the answer. There is other method of doing this, where E2 bar is not getting the red, or E1 bar not red balls. What is the number? Not red balls means only which number? The blue. Therefore, number of not getting red, E1 bar is denoting not getting red. Okay, student. So that is our, in the number form, this blue is 5 in number. So we can write this as 5. Therefore, probability of E1 bar is obtained by N E1 bar, but NS is not to be complemented, student. Okay, from the same NS we have to calculate this bar. So it is 5 by denominator is NS is 8. So you are observing that you will get the same result, maybe expressed in decimal or fraction. So students, questions are very easy. Question number 9, a box contains 5 red marble, 8 white marble, 4 green marble is taken out of the box at random, only one is taken. What is probability that marble taken is red? So for this E1, the red you need to take 5 divided by addition of this. What is that? 5 plus 8 plus 4. You have to write it properly as I have written. Just I am giving you the explanation. So add it, it becomes 17 by 17. Probability of getting the second one, E2 as the white, observe the white only. White is our 8 by 17. Coming for the third one, not green, means it can be your red as well as white. So R plus W, that is one way. So for E3, it can be number of red, means it is our 5, and not green, means it can be 8 also. So it becomes 30. So P E3 is 13 by 17. This is your answer. So this way you have to write everything. Okay, then you have to solve it. So the questions are very easy. Defective and all those things, again the same kind of thing, 20 bulb defective. This defective kind of thing we will do tomorrow. Student, your time is up. So let us stop the class here. We will do more practice on next day, but before that you try to solve all the question, even of the face card. The concept is exactly the same. We will practice more question on next day. So write down your homework. Our 15.1, I think only one exercise is there. Yes, only one exercise is there. Second one is optional. If you can do, please try this one also. It is also only 5 question and very easy. Otherwise, at least this 25 question you must finish. So there is 25 questions. In addition to this, there are some questions which are not belonging to your textbook, but they are also asked, like with replacement kind. Those things we will discuss tomorrow, but you please try with our book also, RC book. You do the exercise question up to, just try with up to the 10. Okay, you will get. So these are the homework. A student, our next class, regarding the next class, tomorrow I may not be